Okay, good everyone. Welcome to my YouTube channel. Now, in today's video, we'll be looking at ideal gas equation. Now, I've done that of Boyle's law, Charles' law, and the rest. You can check it on my playlist. Now, ideal gas are gases that obey Charles' law and Boyle's law. So, the ideal gas equation it is a combination of both Boyle's law, Charles' law, and Avogadro's law. So the ideal gas equation is written as PV equals to nRT. So your P is your pressure, the P is the pressure, the V is the volume, your N is the number of moles, your R is a constant, and your T is temperature. Your pressure can be written as ATM, not for machine, not that one. ATM, 1 ATM, or it can be written as mmHg. So this mmHg means millimeter mercury. Hg is a Latin name for mercury, meaning hydrargyrum. See it here, hydrargyrum. Okay, so now your pressure can be written as ATM or millimeter mercury. So the next one is your volume. So you can see your volume in centimeter cube or in dm. The next one, number of moles. You have your R, which is the constant. Now this R is based on the pressure. If your pressure is given to you as 1 atm, your R will be 0.0821. So 0.821, sorry, not 0.0821. So if it's given to you in terms of ATM, you use 0.821. But if it is given to you in terms of Pascal, which is PA or mmHg, it will not be this, it will be what? 8.31. So the constant, which is the R, depends on the pressure. If they give you a question and the pressure they make use of is ATM, you make use of this 0.821. But if the pressure they give you is in Pascal, PA, or millimeter mercury, you make use of what? 8.31. Okay, so your temperature, as usual, it's supposed to be in what? Kelvin, not in Celsius. Are you with me now? So these are the things you need to pay attention to. I call them the key point in terms of ideal gas equation. Like I said before, they are a combination of what? The Boyle's law, the Charles law, and the Avogadro's law. Now, let us look at the question under ideal gas equation. I forgot to say this. Now, if a question is given to you under ideal gas equation, and the volume given to is in dm cube, you have to convert it to what? Meter cube. Now let's look at this question. They said 500 dm cube of a gas at 30 degrees Celsius and 303,975 pa, meaning pascal pressure, is contained in a vessel. Calculate the number of moles of gas present in the vessel. So like I said, if since this is given to us in dm cube, we have to convert it to what? Meter cube. So the formula we use is what? PV equals to nRT. So my P is my pressure, which is given to me as what? As this. So we have 303,975 times V is what? The volume. Now, how do we convert 500 dm cube to meter cube? What do we do? 500 divided by 1000. Are you with me now? 0 cancel 0. 0 cancel 0. 5 divided by 10 is the same thing as 0.5. 5 here 1, 5 in 10, 2. 1 over 2 is the same thing as what? 0.5. 0.5 equals to n, because they asked us to get the number of moles, times R. Like I said, this is the constant, so it's based on your pressure. Since it's given to us as Pascal, it will be 8.31 times our temperature is what? Degree Celsius. We have to convert it to Kelvin. Come over here. 273 plus 30. 3 plus 0 is what? 3. 7 plus 3 is what? 10. 0 carry 1, 2 plus 1, 3. 303. Now, I want my number of mole to be the subject of the formula. So what do? I'll divide both sides by 8.31 times 303. Divide both sides by 8.31 times 303. So the number of mole 60.36 moles. So that'll be the answer to the question. Now, remember, like I said, your constant is based on the pressure given to you. If it's given to you in Pascal, you make use of 8.31. If it's given to you as ATM, you make use of what? 0.821. And again, like I said, your volume is not meant to be in dm cube. You have to convert it to what? Meter cube. So they give you a question, dm cube, convert to meter cube. If it is in meter cube, use it. Are you with me now? So now I want you to do the next one and tell me your answer in the comment section. Here is the question. They said, determine the pressure exerted by 2 moles of a gas occupying a volume of 200 meter cube at 50 degrees Celsius. So your constant, you're going to make use of 8.31. Now, I want you to do this. Tell me your answer in the comment section. So don't forget to subscribe and turn on the notification bell to receive more videos like this. See you in my next video. Bye.